So we answered our first question, that is, what is distribution? Now we need to answer our second question, and that is, what is central tendency? And tomorrow we'll be talking about our third question, that is, what is dispersion? Okay, so let's tackle central tendency first. Central tendency is not one statistic, but a class of statistics. And this class of statistics is used to describe or indicate the most typical values in a distribution of values. Right? So, and you might ask, what do you mean by typical values in a distribution? Well, that's a very good question. It turns out that there are at least three meanings of this phrase. For value to be typical, it could mean one of the following three situations. The first type of central tendency statistic is called mode. So when we're looking at mode, being typical means being the most occurring, or a value that occurs the most often. We can also say that to be typical is the value to be expected, right? And then if we define typical in this way, then we're talking about means. And there's another name for mean is average, right? That's sort of a more common term for mean, but for various reasons, we use mean more often. Lastly, to be typical could mean that a value is at the center of the distribution. And if we define typical in this manner, we're talking about medians. So you might ask, well, wouldn't these three be the same, right? Isn't the most occurring value something that we expect? Also, isn't and the expected value always at the center of the distribution? Well, the short answer is no, right? The expected value doesn't have to be at the center of the distribution, and the expected value doesn't have to be the value that occurs most often. And obviously, the value that occurs most often does not have to be at the center of the distribution. There's one case where these three cases would overlap, would converge. That is, the most occurring value is the expected value, and the expected value is also at the center of the distribution. There's one situation where that would occur, but in many cases, these three typical values are different, and that's why we have different names for them. Okay, so let's look at these three typical values one by one. So mode is the value that occurs most frequently. That's a very straightforward definition, I hope. And let's see whether we really understand that. So in the following, I will give you a string of numbers or values, and your job is to identify the mode, given that mode is defined as such. All right, 1, 4, 3, 3, 5, 6, 7, 9. What is the mode? You might want to pause before, hearing my answer. And the answer is 3, right? Because we have two threes. And we only have 1, 1, 1, 4, 1, 5, 1, 6, 1, 7, 1, 9. So 3 is the value that occurs most often, right? Most frequently in this string of values. So the mode is 3, right? So we say mode equals 3. Okay. 1, 4, 4, 2, 1, 3, 3, 3, 4, 9. what is the mode? Or more precisely, what are the modes? Aha, I may say, if the question is asked that way, then we easily have two modes because we have 3 fours and 3 threes, whereas we only have 2 ones, 1 2, and 1 9. So here we have two modes, which is entirely possible, right? 3, whoops, 3 and 4. Okay? So modes doesn't have to be a single value. There could be multiple modes for any distribution, right? So with regard, this is a sort of a sample value, right? A sample, first person scored 1, second, third scored 4, the fourth person scored 2, all the way to the last person who scored 9, right? So this is sample value, and we say, well, within each sample, or within a given sample, there could be multiple modes, as in this case. Okay? So we can easily sort of identify the mode given a histogram. So if I ask you, well, where's the mode? Given that on the x-axis we have the value of the variables, and on the y-axis we have frequency, right? The number of times that each value occurs. Very easily, you would say, mode is right here, because value, well, I should say value, right? Mode is here because value is on the x-axis. So this is the mode because it occurs the most often. Okay? So if we only have one mode, we'll call this distribution a unimodal distribution. Uni means one, right? Mode is the adjective form of modal is the adjective form of mode. So this distribution is called a unimodal distribution. And if we have unimodal distribution, you might sort of expect that we also have multimodal distribution, right? In this case, very quickly you can identify there are two modes, right? Or these two values. These two values, right? These two values occur the most often, or more often than the remaining values, right? So in this case, we'll call it a bimodal distribution, right? Bi means two. Modal, again, the adjective form of mode. So whenever you hear people say, well, I have a bimodal distribution, then this person essentially says, there are two values in my sample that occur, equally often and most often as well, more often than the remaining values. Okay? So mode is a very useful descriptive statistic because it can apply to all kinds of data. We said that we're have different types of data, right? We have nominal data like men, women, right? Whenever we're talking about categories, we're talking about nominal data. We have ordinal data as well. Education, right? We have bachelor's degree, master's degree. We have PhD, right? So these are categories, but these categories are ranked, right? PhD is more advanced than master's. Master's is more advanced than bachelor's, right? So it's ordinal. And then we have interval ratio data, right? So it's, basically, it's a kind of ranking with equal intervals, right? And the only difference between interval and ratio data is whether there's a true zero somewhere. Okay? All right, so as we said, mode can describe all kinds of data, right? So for example, if I say that in my sample there are 14 males and 35 females, then what's the modal? What's the modal sex, right? Well, female, obviously. If in this class, right, we're talking about socioeconomic class, obviously socioeconomic class is an ordinal data, is an ordinal type of data because we not only have categories but we also rank them, right? So here we can ask, what is the modal class? Well, obviously it's lower class. We can ask, if on a 7-point scale on a certain issue, 1 indicating very opposed, 7 indicates very support, and if in this sample 60% of the respondents chose 5, we can ask, well, what is the modal response? Well, obviously the modal response is 5 because 60% is the majority. There can be another 60% of another response because we can't have a percentage that's larger than 100% for one given sample, right? So this is the clear majority, so the modal response is 5. Okay, that's mode. Pretty simple, huh? Very straightforward. Um, the next type of central tendency statistic is what we call mean, right? Mean, very intuitively, is the average value in a sample. Okay, and I assume that most of us know how to compute an average value. So here I will only like to draw your attention to the restriction of computing means. That is, we can only compute means or averages for interval and ratio data. We cannot compute mean values or averages for nominal data for very obvious reasons, I would say, right? So for example, we have nominal data, male, female. Then what do you think is the average of male and female, right? That doesn't make sense. It doesn't exist. Or, we have Democrats, Republicans, and independents. So these are the values for a nominal data that we can call party affiliation. Then again, we cannot compute means for these three values, not only because they are not numbers, because we can easily assign some numbers to them, right? So we can imagine that we assign 1 to Democrats, 2 to Republicans, 3 to independents, and we'll say, well, let's compute a mean 1 times plus 2 plus 3 divided by 3. So what's that? Is 2, right? Exactly. 6 divided by 3 is 2. How would say, well, the mean for people's, party affiliation is 2, and 2 here is Republicans. Wait, that doesn't make sense. I mean, how can you say that average, Democratic political affiliation is average? Why it is not independence? Right? Independence makes more sense if you average Democrats and Republicans, it give you independence. But it turns out that people, self-identify as independents, they're not holding some kind of attitudes as an average of Democrats or Republican ideals, right? They hold different ideology. So my point here is that you cannot compute mean scores for nominal data. Okay, so these are nominal data. Nominal. Can you compute mean scores for ordinal data? So ordinal data, we have lower class, middle class, and we have upper class. Okay. Again, because these are discrete values, they're non-overlapping, right? They indicate different categories of people. So again, you cannot compute averages. That doesn't make sense, right? Even though intuitively we'll say, well, isn't the average of people's socioeconomic class bit of middle class? Well, it doesn't have to be, right? Um, it doesn't work that way, right? It's not like the average of low and high, low upper is middle. It doesn't happen that way, right? So just remember that mean values cannot be computed for nominal or ordinal data. It can only be computed for interval and ratio data. Okay. All right. So to understand better how we compute means, let's have some notations. So, oh, what's going on? So let lowercase n indicate sample size, and let xi as the ith observation or case in the sample, right? So it's very easy to imagine, right? We can have one person, the second person, the third person, da da da, the ith person till um, the 100th person. Okay. So really this I can indicate any value between 1 and 100, including 1 and 100, right? So this will give us the abstract notation for a certain observation in a sample. Okay. And then we use m as the sample mean. Um, that makes sense because mean, that's the first letter of mean, right? The word mean. So mathematically, we express mean as this expression. First of all, we have the summation, with the sum of all values, individual values in a sample, right? So this is the summation expression. So where this whole thing equals to the sum of all individual values, right? It looks sort of formidable and scary, but it's not, right? It's just a shorthand expression of summation, which we all know what to do, right? With this formula, and we know that to compute averages, we simply add everything up in a sample and divide the sum by the number of observations or sample size. Okay. All right. So let's see if we truly understand how to compute means. So recall we saw data on the murder rates of all 50 states in the United States. And this time, if you have individual values for each of 50 states, it's very easy to compute an average murder rate for the 50 states, right? You just add up all 50 scores, divide the sum by 50, you will have the average. But sometimes you don't have information like that. Sometimes you're given information in this way, right? You're told that, southern states, which there are 16, have an average murder rate of 10.47, whereas the northern states, there are 34 of them, right? And they have an average murder rate of 5.87. Okay, and now you're asked to find the average murder rate across all 50 states, right? So 16 plus 34, that gives you 50. So how do we find this mean murder rate? I'll give you 2 seconds to think about it, and I will discuss the answer. So if you want to solve this problem for yourself, you might want to pause here before hearing my explanation. Okay, so you think, well, this is easy. We have two values. That's sort of like the x's here, right? So we have the first x is 10.47 plus, okay. So we have x1 as 10.47, the second x as 5.87, right? And then we have n here, very easy. The total is across all 50 states, right? 50. And then, okay, we just need to compute these values. And let me find my calculator so that we can do this together. So you would say the sum of 10.47 and 5.87 is exactly 1634. And 1634 divided by 50 is 0.3268. So the average murder rates across all 50 states is this. Or you say, Andrew, that doesn't look right. Because we don't really have 50 score here. We only have 2, right? This is the first x, this is the second x. So we shouldn't divide the sum, which is 16.34, by 50. We should divide it by 2. And that will give us 16.34 divided by 2. That will give us 8.17. That looks better than 3268, right? It looks about right. It's a bit lower than southern states. It's a little bit higher than northern rates. That makes sense. Mean or average is at the middle, right? Okay, if you use the first method and obtain this number, obviously you got it wrong. And if you use the second method and got this number, you also got it wrong. Okay? So the correct answer to this question, or to obtain the correct answer to this question, we need to understand a specific type of mean. And this type of mean is called weighted mean. Okay? So this is the mean of subgroups. So southern states, northern states, there are 2 subgroups, right, that have unequal sample sizes. See, the sample sizes here are unequal. 16 obviously is not equal to 34, right? So, and then, each subgroup has a mean of itself, right? So the mean for this subgroup, the southern states, is 10.47, and the mean for the subgroup of northern states is 5.87, and they have different sample sizes. So to compute a mean of these 2 subgroups, we need to understand how to compute weighted mean.